People have joined.
Hello, everyone. Can you hear me? Can you hear me? Can someone hear me?
Yes, sir.
Oh, is that Farida?
Yes, sir.
Hey, how are you?
Thanks, sir.
Okay, we'll start exactly 4 o'clock. This is 1 minute to 4. Exactly 4 o'clock. It's going to be a long, interesting class. So I know today is Children's Day, right? Well, maybe this is my Children's Day gift to you guys. Yeah, I just believe that this will be a class that you'll be thankful that you attended. Yeah. So I hope we can roll from now to like 6:30 to cover everything that we have to cover. So the sacrifice on my own part too. So I hope that you will consider it a sacrifice too. Yeah. So if you have a friend you want to call your classmate, I mean, you want to call to join in or message to join in. Yeah. So yeah, Dabira. Okay, Dabira is there. Daniela, how are you? Eniola,
I'm fine, thank you, sir.
yeah, Pamela Rain, Tinola. Okay. So this is exactly 4 o'clock. So I'm going to be starting straight away. Yeah, so I believe those who are here are those who are interested. Okay. So just kick start. So we are going to be looking at these topics. Okay. Yeah. Application of equilibrium, that's chemical equilibrium. Then we'll move on to metals, reactions, and uses of metals. Then that will link to reactivity series. That will take us to redox reaction, underneath reactivity series. And of course, we'll put that on extraction of metals, maybe looking at extraction, of iron. And if we are able to cover this, I think it will be a great thing to have covered some of the things that some of you may have missed in class. So as the lesson goes on, I will appreciate if you don't understand anything, stop me and I'll be able to explain again. That's why it's called a reinforcement, class. So let's kickstart with chemical equilibrium. Chemical equilibrium. So your syllabus, that's under application of chemical equilibrium. Your syllabus want us to look into this aspect with respect to application of chemical equilibrium, right? So, but usually the basis of chemical equilibrium starts with you understanding what equilibrium is. So, for example, if you have a question that asks you to describe, what chemical equilibrium is, or to describe chemical equilibrium or give features of dynamic equilibrium, what are the features that you will state? Anyone want to jump in? Yeah, features of dynamic equilibrium.
The concentration of products and reactants are the same.
Okay, in dynamic equilibrium, concentration of products and what? And reactants. Okay, the equilibrium concentration of product and reactant remains the same. Yes, one other point. One other point that you could give. Yes, any other person?
It's a reversible reaction.
Okay. It's a reversible reaction, yeah, but that is not a key features of dynamic equilibrium. So, yeah, it's a reversible reaction. Reversibility will lead to that, right? But what will lead to, let me show you a typical a question. This is, for example, a past paper, right? You can see they are talking about reversible and they are saying explain the term equilibrium, Yeah, so they can ask you to explain the term dynamic equilibrium. Okay. So if they ask you to explain the term equilibrium, the term dynamic equilibrium, it's not just talking about reversibility, right? So like someone mentioned earlier, number one point, when you are asked to explain the term dynamic equilibrium, okay, it's a reaction or is a state in which the rate of forward reaction equals to the rate of what? Backward reaction. Number two, the equilibrium concentration of reactant and product remains what? Constant. Do you get that? And all this will happen if the reaction is a reversible reaction. So if it's not a reversible reaction, you won't even talk about what? Equilibrium. Okay, so it is possible for a reaction to be reversible, and yet the reaction has not attained the state of equilibrium. So when it has attained the state of equilibrium, okay, which we call dynamic equilibrium, it has certain properties. And that properties, key out of those properties, number one, the rate of forward reaction equals what? The rate of backward reaction. Number two, equilibrium concentration of reactant and product remains what? Constant. Is that taken? Okay. So then we look into some other things about chemical equilibrium. We talk about factors that affect chemical equilibrium. What are those factors? Quickly. Factors that affect chemical equilibrium. What are those factors? Temperature, yes. Pressure, any other thing?
I think
temperature, pressure, and what? Factors that affect a reaction at concentration. And so I believe that you
is that
at this point you are,
I'm not saying proud.
Tolu and Ikuti, please, you want to mute yourself if you are not contributing constructively to the lesson. Okay? So, thank you. So we'll then apply that to two reactions, Haber process and contact process. Your understanding of the factors that affect the position of equilibrium is what you are going to apply to what? Explaining Haber process and what? Contact process. So while we are explaining Haber process and contact process, we'll try to look into how those factors affect the position of what? Equilibrium. Now, for example, looking at Haber process is a process in which ammonia is what? Is produced, right? So we want to see what is the application of chemical what? Equilibrium to this process. How does chemical equilibrium affect the Haber process? Okay, so one of the things that you may be asked under this is, number one, what are the reactants in Haber process? Nitrogen and what? Hydrogen. The product is what? Ammonia. So they will ask you what is the source or what are the sources of nitrogen and what? And hydrogen. Okay. So, of course, you know nitrogen is found where? What's the source of nitrogen? The air. Air is a mixture of what? Of gases, right? You know the percentages of gases we have in what? In air. Oxygen 20 or 21%, nitrogen, 79 or 80 what? 80%. So nitrogen is abundant in air. So air is a source of nitrogen. Now, when it comes to the hydrogen required for the Haber process, what are the sources of these possible sources of this word hydrogen? The hydrogen can be gotten from methane, which is what called the natural gas. So you can get hydrogen from that, okay, from methane, natural gas. Then, of course, when hydrocarbons are cracked, from the cracking of hydrocarbons are compounds that contains only carbon and what? Hydrogen. So when you crack them, cracking them means that when you break this hydrocarbon down, you can get what? You can get hydrogen. For example, if you look at this, when we break down, ethane, we can get what? Ethane and what? Hydrogen. For now, you may not know what ethane is, but just know that when you crack your hydrocarbons, you can get what? You can get hydrogen. So these are the two sources of what? Of hydrogen. From what? Methane, which is the natural gas, right? The cooking gas. And of course, from cracking what? Hydrocarbon. Maybe if you are stating this in exam, you don't just say hydrocarbons, right? Just tell us from what? The cracking of what? Hydrocarbons. That will give you your full complete mark. So we have been able to look at the sources of what? Nitrogen and what? And hydrogen, right? As stated by your syllabus. Okay. Then what are the conditions for Haber process? That's the next thing that you need to know. Conditions for what? For your Haber process. Okay, so we'll talk about conditions, pressure. Okay, then we'll talk about another condition, what? Temperature. So our focus under this Haber process is we want to see how changes in these conditions can affect what? The yield of ammonia in what? In Haber process. So the pressure, these are white hats. You need to memorize and remember them, and of course then understand how those factors affect what? Equilibrium. So we have pressure, and this reaction occurs at a pressure of what? 200 atmosphere, okay, or 20,000 what? Kilopascal, which is 200 atmosphere. Just remember it in atmosphere. While the temperature is what? 450 degrees Celsius. If you look at contact process, the two conditions seem similar. Contact process is the temperature is 450 degrees Celsius, while the pressure is 2 atmosphere, 1 to 2 atmosphere. So don't confuse them, right? Contact process is lower in pressure than what? Than Haber process. As a teacher, or since I learned it, how do I remember it? When I hear the word contact, for me, I just associate with come down, right? From 200 to 2. So I know that contact process come down. So the pressure is 2, while Haber process is 200. That's the way I do association and remember stuff, right? So both of them have the same temperature, 450 degrees Celsius, but Haber process pressure is 200 atmosphere, while contact process pressure is what? 2 atmosphere. I hope I'm communicating. If you are with me, just do thumbs up, or you say yes, then I'll know you're with me.
Yes, sir. Well,
okay, so then what about the other thing required, the catalyst? Because both of them require catalyst. The catalyst in Haber process is what? Is iron. Okay, some will say finely divided iron. Finely divided what? Divided iron. What finely divided simply means that it's powdery iron. Okay, divided what? Iron. And of course, you know why it is finely divided, because the smaller the particle size, the higher the surface area. And so the higher the surface area, the better it is for what? To increase the rate of reaction. That's just the reason behind that. Okay, so these are the conditions required for what? For Haber process. Now we know what the Haber process is. Let's now apply chemical equilibrium to this. So we have a reaction in which that's Haber process, in which your nitrogen, okay, react with your what? Hydrogen to form ammonia, right? We can balance the equation. This is balanced. So if this was a reversible reaction, so we know it's a reversible reaction now. So how do we apply reversible reaction to this? We are looking at two conditions here. pressure and what? And temperature. So if we increase the pressure, you could be asked questions like this. How will increase in pressure affect this reaction? So there are two things you are focusing on. You are focusing on rate, and you're also focusing on what? Yield. Please, I need everyone's attention to look at it. You are focusing on rate and what? Rate and yield, right? So if I increase pressure, let's look at pressure first. If I increase pressure, how does it increase the rate of reaction? Anyone? Increase in pressure does what to rate of reaction?
Increases.
Increases.
Increase in pressure increases what? In terms of rate.
It increases the yield, sir.
Okay, so let's talk about rate first. Increase in pressure will also increase rates, right? Go, because for all reaction, increase in pressure increase rate, increase in temperature increase rate, increase in concentration increases what? Rate. Presence of catalyst increases what? Rate, right? Now let's consider the yield of reaction. For us to know the effect of increase in pressure on the yield of this reaction, we have to consider something. And what is the thing that we have to consider? We have to consider the moles, right, of reactant and product. What are the moles of reactant and product here? We have 1 mole of what? Nitrogen, and 3 moles of what? Hydrogen. So everything on the reactant side, we have what? 4 moles, right? While on the product side, we have what? 2 moles. The coefficient here is what we refer to as moles. Here is 1, because nothing is written, it means it's 1. Here is 3. Okay? If you don't understand, just ask questions. So we have 4 moles here, we have 2 moles here, right? So for a reaction like this, increase in pressure will favor the side, okay, with smaller moles. Okay? Increase in pressure will favor the side with what? Smaller moles. What does that mean? It simply means that the equilibrium will shift to what? To the right-hand side. Because the right-hand side is the side with what? With fewer moles. So let me write it as a clue. Increase in what? Pressure favors where? Favors the side with what? With fewer moles, and vice versa. So decrease in pressure will favor what? The side with what? More moles. So for this Haber process, the side with fewer moles is the side where the product is, which is ammonia. So that tells us that if the equilibrium shifts to the side where ammonia is, what happens to yield? Will yield increase or decrease? Anyone? Will yield increase or decrease?
Side to increase.
It will increase. So there will be an
Side to increase.
Yes, there will be an increase in yield, because that is the side of fewer moles, and that is where you have your word ammonia. So in exam, these are questions that you possibly could be asked, right? They could ask you to explain the effect of increase in pressure or increase in temperature on the yield in Haber process. So you're going to tell us what will happen, then you explain why it's going to happen. So what will happen is that there will be an increase in yield. Then the next thing is, why would there be an increase in yield? The simple explanation is because increase in pressure favors the side with fewer moles, right? And the side with fewer moles is the side where you have what? Your product, which is ammonia. So equilibrium shifts to what? Shifts to the forward direction. Or you say the equilibrium favors what? Favors the forward direction, or equilibrium shifts to the right-hand side. That's the way to explain that. So of course, you know what will happen when you decrease what? When you decrease in pressure. If you decrease pressure, it's going to be the opposite, right? If you decrease pressure, what happens to rate? Rate will decrease, okay? But what happens to yield in this particular reaction too? There will be a decrease in what? There will be a decrease in yield, because decrease in pressure will favor the side with more moles. And the side with more moles is pointing to what? The backward direction, right? It's pointing to the backward direction. So you can see that effect, right? So let's look at temperature. Let's look at temperature. Increase in temperature. I want someone to explain this. Increase in temperature. What do you think it will do on rate and yield? Increase in temperature. Quickly. Anyone volunteer? Yes, go ahead. Go ahead.
To increase the rate of reaction
Okay, to increase the rate of reaction, yes.
for yield.
What will happen to yield? Increase in temperature. So we need to know first, right? Before we know, we need to know, is this reaction exo or endo?
I think reaction is exothermic.
Yeah, so this particular reaction is what? Exothermic reaction. How do you know? They will put your delta H equals to what? Negative. They can say negative 100 kilojoule. That tells you that the forward reaction is what? Exothermic. So if the forward reaction is exothermic, then and the backward will be endothermic. So can you then explain now?
Oh, sorry. Can you repeat what you just said?
So we say that before you can tell the effect of temperature, you must know, is the reaction exo or endo? Is the forward reaction exo or is the backward endo? You have to determine. How will you know that? So if they write any reaction, let's say I say A plus B, reaction A plus B give me C. I will check the sign that is written here. This sign is called enthalpy change, right? Is it positive or negative? If they put positive 100 whatever kilojoule, that tells you that this forward reaction is what? Endothermic. But if they put negative value there, it means that the forward reaction is what? Is exothermic. I hope you can remember your enthalpy. Negative sign means exo, right? Exothermic. While positive sign means what? Endothermic. Is that taken? So for Haber process, this reaction is an exothermic reaction. So what does increase in temperature do to an exothermic reaction? Anyone? Increase in temperature, what does it do to exothermic reaction? There is a clue, a very funny clue. Yes, go ahead.
I think it reduces the yield.
Okay, it's going to reduce yield because increase in temperature favors what? Endo. And endothermic is the backward direction. That tells you that equilibrium will shift backwards. So when equilibrium shifts backwards, less and less products will be what? Formed. So because exo hates what? Hates what? Heat. Right? Why endo likes what? Endo likes what? Likes heat. So that tells you that when for an exothermic reaction, if you increase the temperature, you are disfavoring it. So increase in temperature here, why it increases rates, what does it do to yield? It will decrease what? It will decrease the yield because the forward reaction here is exo, but the backward is what? Endo. An increase in temperature favors endo. Endo is backward. That means your ammonia will break down. So you are going to be having less and less what? Ammonia. Okay? So then they will then ask you, so if increase in temperature increases the rate of reaction, right? So why can't they continue to increase, the temperature? The simple answer is if they increase the temperature beyond 450, okay, they are going to be having less and less what? Ammonia produced per time. They could also ask you, so if increase in pressure increases rates and it increases yield, why can't we do this reaction at a pressure of something like 1,000 atmosphere? Since increase in pressure will increase both rate and yield. Does anybody want to attempt that question? Why can't we over increase the pressure for this reaction? Why do we just use 200 atmosphere? Why not 1,000, 2,000 atmosphere?
Is it because
That's a combustion reaction.
not safe in a lab in that kind of environment?
Okay,
so very high.
Yeah, that's correct.
So
So
it's expensive.
It's expensive.
it's expensive. So why is it expensive? Number one, you need to build stronger pipes to be able to contain the pressure. Do you understand? You need to build stronger pipes. That's why it's expensive. So you won't just say it is expensive. I mean, you are supposed to explain in exam to get your marks. So it's increasing the pressure will make the process a very expensive process because, do you understand? You need to build stronger pipes to be able to contain the pressure. So that is understandable. Okay. And of course, to generate pressure, maybe you are going to generate pressure through hydroelectric or something. That's going to cost electricity to also do that. Do you understand? So that's why it's going to be what? Expensive. So apart from the fact that it's going to be expensive, issue of safety is not safe because the pipes can burst at any time. So this is why they do what they do in what? In industry. So they choose what we call a compromised temperature. Yeah. Okay, the pipe can burst, right? Maybe not combustion, but the pipe can burst, right? It's not safe. Issue of safety. Okay. So I think that is understandable, right? So let's move to the next thing, which is what? Contact process. I'm just taking it tutorial so that we'll move on. I have a lot to cover for you. Okay. So application of equilibrium to contact process. So just like we look at for ammonia, right? What are the things that you need to focus on for contact process? The same thing, you need to focus on what are the sources of sulfur. Okay, contact process, sources of sulfur. Okay, then you also look at the condition, pressure, temperature, and catalyst that is what used. You can see that they are similar. Okay, has any of you come across the sources of sulfur? What are the sources of sulfur for contact process? Sources of sulfur, quickly. Anyone? Just jump in, no time. Sources of sulfur, anybody? Sources of sulfur.
There was.
So you can be mined.
Okay, from the mine, we have, yes, from where we have what we call natural source of sulfur. That is the sulfur bed. We have sulfur bed. Okay, sulfur bed. Okay, they can get it from there. Number two, they can get sulfur from what? From sulfur containing fossil what? Fossil fuels, right? Like petroleum, e.g. petroleum. Okay, e.g. petroleum. So if petroleum contains sulfur, when you burn the petroleum, like let's say methane, for example, okay, the source of petroleum contains sulfur. When you burn or you combust your petroleum, you're also going to burn, when you form carbon dioxide and water for your petroleum, if sulfur was present, that sulfur will also burn, okay, to produce what? Sulfur dioxide. So they could ask you sources of sulfur what? Dioxide, okay? So your contact process is basically a process that leads to the production of what? Sulfuric acids, okay? Leads to the production of what? Sulfuric acid, right? So in the production of sulfuric acid, we have certain reactions that you must know, okay? We have certain reactions that you must know, and that reaction includes this particular reaction. So we are going to be starting from sulfur, right? We'll then look into the production of what? Sulfur dioxide, like I just explained here. How do you get your sulfur dioxide? When you burn sulfur or you roast what we call sulfide ores, like hydrogen sulfide in oxygen, you can get what? You can get your sulfur dioxide. So I'm going to be showing the example here, okay? So when we say when you burn sulfur or you burn sulfide of sulfur, that means the ore of sulfur, right? Like hydrogen sulfide. If I burn sulfur, okay, I'm going to be getting what? Sulfur dioxide, okay? Or if I burn something like hydrogen sulfide, okay, I'm still going to be getting sulfur dioxide and what? And water. So if I burn something like this, okay, in oxygen, I'm going to be getting SO2 plus what? Plus H2O. Okay, gases, okay? But we are going to be focusing on just burning what? Sulfur, right? Or they call it roasting sulfur in excess oxygen. So your contact process has what? Three, you know, 3 or 4 equations, right? The first one is you are burning your what? You are burning your sulfur in what? In oxygen. So when we burn sulfur in oxygen, we form sulfur what? Dioxide. Then the sulfur dioxide formed, then further react with what? More oxygen. But this reaction, out of all the reaction, is the equilibrium what? Reaction. Can you see where equilibrium comes in? You need to know this reaction is what? Is the equilibrium what? Reaction, right? And the reaction is not only, you know, equilibrium reaction, it's also what? It's also exothermic, right? So the reaction is what is an equilibrium what? Equilibrium reaction, right? So when you form your sulfur trioxide, what else will be required? This reaction will require catalyst. That's that equilibrium reaction requires catalyst, require pressure, and requires what? Temperature, right? Okay, so what is the pressure? So now we want to look at condition now. Condition number one, the pressure. What is the pressure? Anyone? Temperature?
Pressure is
Yeah, go ahead. Just,
temperature.
pressure is what? 2 atmosphere. Yes. Temperature is what? 450 degrees Celsius. Catalyst is what?
Vanadium oxide.
Vanadium 5 oxide. Okay, they could even ask you to write the formula. Please note the formula. That's the formula. V2O5. Vanadium what? 5 oxide. Vanadium 5 oxide. Vanadium 5 oxide. So these are the conditions for the Haber process. So this is the only reaction here in the Haber, in the contact process that is a reversible what reaction. So if it's a reversible reaction, it means that the application of equilibrium will come in here. But let's first run through the contact process. You need to know all the processes, all the steps. Step one, burn your sulfur or roast your sulfur in oxygen to form sulfur dioxide. Step two, sulfur dioxide form is further what? Oxidized to what? Sulfur trioxide. And that reaction is the equilibrium what reaction, right? Okay. Now the sulfur trioxide formed will need to be converted to sulfuric acid. But how is it converted to sulfuric acid? It's not going to be dissolved directly in water, even though it's an acid anhydride. It's going to be dissolved in what? In what we call oleum. Oleum. That's where we dissolve what? We dissolve we'll dissolve it in concentrated sulfuric acid to form what we call oleum. Then the oleum will now further what? Give us what? Give us the sulfuric acid. So I can go ahead to write that. So we'll do SO3 plus what? H2SO4. It's going to give us H2S2O what? O7. Please, you need to know this equation. This guy is called what? Oleum. Right? So how do we then get sulfuric acid? The oleum is now further dissolved in what? In what? In water to then form what? Sulfuric acid. So we have 2H2SO4. Please, you need to know this equation. So how many equations do we have now? Number one, roasting of sulfur. Number two, converting sulfur dioxide to what? Sulfur trioxide. Number three, dissolving sulfur trioxide in what? In sulfuric acid to form oleum. And number four, dissolving oleum in water to form what? Sulfuric what? Acid. That's the process. Okay? That's the process, right? So they could ask you, why is it that they do not dissolve the sulfur trioxide directly in water? When they do that, it produces a misty film. Okay? It produces a what? A film, a misty what? Film, right? And that film is very toxic. So they dissolve it in what? In sulfuric acid first. So they use sulfuric acid to capture it. Then they will not dissolve the sulfuric acid in what? In water. Meaning that they not dilute the sulfuric, dilute the oleum, dilute the oleum in what? In water to form sulfuric acid. So these are the four processes we go through for what? For contact what? For contact process. Okay. So let's see how equilibrium applies in contact process. So what is the equilibrium state? The equilibrium reaction. There is SO2 plus what? Plus O2 to form what? To form 2SO3. Okay, yeah, to form 2SO2. So we can balance the equation 2 here. Yeah, I think it's balanced, right? So they could ask you several questions, underneath this this reaction, the condition, for this. Now, number one, I told you that something about this reaction. The reaction is what? Exo what? That means the forward reaction is what? Exothermic. So if the forward is exo, the backward is what? Endothermic. Right? So let's see the effect of increase in pressure on yield, You already understand that it's going to increase rate, but let me just write rate and what yield so that you put everything in perspective. I want to finish this contact process before we have a timeout. Then you log in again. So increase in pressure, right? So when you increase pressure, what is the effect on rates? Anyone? Effect on rate, increase in pressure, effect on rate. Quickly.
Rate increases.
Okay, so it's
Rate
going to,
increases.
yeah, it's going to increase rate. What is the effect on yield? Effect on yield.
Side with less moves.
Good. Okay, so increase in pressure, that means equilibrium goes to the side with what? With lesser what? Moles, right? And the side with lesser mole is the side of our product. So that tells us that the pressure will increase what? Yield, right? So that means we are going to be having what? Increase in what? Increase in yield of what? SO3. Is that taken? Good. So let's look at increase in temperature. Increase in temperature. How will it affect this reaction? Yes, anyone? Increase in temperature.
Increase in temperature will increase the rates.
Okay. Increase in temperature will what? Will increase the... Did you say increase the yield or decrease
Increase the rate. Increase, I said...
Okay, increase rates.
Favor, yeah, I said rates. But for you, it will favor the reactant side.
Okay, so that means equilibrium will shift to the backward what? Direction,
Backward
right?
direction.
So that means you are going to be having less what? Less yield, right? Less yield of what? Of SO3, isn't it? So we're going to be having a lesser yield of SO3. Okay, so that's what is going to happen there. So you should be able to explain this for increase in pressure, decrease in pressure, or decrease in pressure and decrease in what? Temperature. Okay, so this is what we call application of chemical equilibrium in what? In industry. So just two things: contact process and what? And Haber what? Haber process. Okay. So before we get to properties of metals, that's when we'll log in again when this thing times out now. So let me see if I can get a question to just dazzle through for contact process. Quickly. Contact process. Just need a question on that. Okay, I can get a question on that. Okay, so let me give someone opportunity to just reiterate 30 seconds before this thing logs out. 30 seconds. Application of chemical equilibrium to Haber process. Anyone? Yes. Who wants to just explain what you learned or what you are able to reinforce on Haber process? Tell us the condition and stuff. Yeah, go ahead, please. Yes, I'll put the slide and annotation on Google Classroom. I will do that. For those who are not able to catch up. Yes. I have 1 minute before this logs out. Anyone? Or you have question to ask? You have question to ask? So when we log in again, we'll just go straight to metals. Don't forget that we have these topics to look at. We have taken one of them now, which is chemical equilibrium. So we'll go straight to metals, reactions, and uses. Okay. No one has question, right?
So I have a question.
Okay, go ahead.
If it were to be a 5-mark question, and they ask us how does an increase in temperature affect the rates, affect the yield of
Yes.
ammonia, how will we answer that question?
Okay, so thank you. Number one, you are going to tell them what will happen first. What will happen is increase in temperature will increase